This assignment's pretty easy. I think the only problem is just paying attention to the x-axis. You know, if you look at these labels, it goes 10, 20, 30, 40, 50. These go 1, 2, 3, 4, and so on. So that's the only difficulty, I think, with this assignment. But it's still that same idea. Y-intercept is that starting point. Slope is that rate of change. X-intercept is that ending value. They're going to be giving you some of these things. So a battery with 20% of its full capacity is connected to a charger. So it's starting at 20%. So boom, we know that the capacity percentage-wise, in other words, the y-intercept at the start is 20. So we're going to take one of these points and drag it over here. Then, every minute that passes, an additional 5% is charged. So every 1 minute, this is time in minutes, just to double check. So every 1 minute is going to go up by 5%. So that would go up. So 1 minute, some people might put the point here, but really it's going up by 5%. So you just got to be careful. That's going up by 5% right there. Or if you want to, you can do 2 minutes is 10, right? Because 5% in 1 minute is the same as 10% in 2 minutes, which would be this point. Your choice. You could put the point there as well, either one. Quinn returned home one summer's day to find it sweat-inducingly hot. He turned the air conditioner on and fell asleep. The room's temperature decreased by 5 degrees Celsius each minute, and Quinn woke up 60 minutes later when it was 10 degrees Celsius. So he woke up 60 minutes later when it was 10 degrees Celsius. This is telling me that after 60 minutes we have a temperature of 10 degrees. So if we look here, when time is 60, we have a starting value of 10. All right, that's great. Let's look at the slope now. So the room's temperature decreased 0.5 degrees per minute. So 0.5 per 1 minute. Now look, this doesn't do increments of 1 minute. It does increments of, well, you could do 5 minutes or 10 minutes. So wouldn't this be the same thing as 5 every 10 minutes? And it's decreasing by that amount. So if we go backwards, because if we go down 5 for every 10 minutes, this point would be here, but I don't think they'll allow us to do that. So we're going to go backwards. We're going to go up 5 and to the left 10. So up 5 and to the left 10. It should be a negative slope because it's decreasing, right? The room temperature is decreasing. If you read through that problem again. But right there would be a good spot to put that point. I mean, you could do 20 minutes if you wanted to, right? 10 over 20. Either way to think about it, but put the points there, and that'll be correct. A pool has some initial amount of water in it. They don't tell us what that is. Then it starts being filled, so the water level rises at a rate of 6 centimeters per minute. So we have a slope of 6 centimeters per 1 minute. You know, and you can rewrite that as 12 over 2. Or in our case, look, it's going in increments of 5. Wouldn't that be 30 over 5? Because 6 times 5 is 30. You're just multiplying by the same thing on the top and the bottom. 6 times 5 is 30. 5 times 5 is, or 5 times 1 is 5. So anyways, after 20 minutes, the water is 220 centimeters. So 20 minutes right here, we have 220 centimeters. So that would be right here. So we need a second point. We're going to go up 30 for every 5. So if I'm going to go backwards, I'm going to go down 30 and to the left 5. So down 30 would put us at 190, which would be right here. And then to the left, 5 would be right here. Just got to be careful. So that's a way of going up 30 and over 5. Last one, Rip Van Winkle fell asleep for a very long time. When he fell asleep, his beard was 8 millimeters long. And each passing week, it grew 2 additional meters. So he started at 8 meters. Started at 8 meters long, and then for every week it goes up by 2. So slope is 2 over 1. Notice our times in weeks, which is the same thing as 4 over 2. So if I go over 2, I'm going to go up by 4. Place the point right here.